talk about the absorption of amino acids from protein. So you eat your baked potato, it's got starch, it's got butter. Let's say it's got bacon, right? So a little bit of protein. The protein was hydrolyzed by pepsin in the stomach. It was hydrolyzed by trypsin, chymotrypsin, and carboxypeptidase in the small intestine. Right? These were the enzymes that the zymogens from the pancreatic acinar cells delivered, and then enterokinase got the ball rolling for conversion into these enzymes, which then digest oligopeptides into smaller oligopeptides. So that's what's going on here. Gastric and pancreatic proteases, peptidases, making oligopeptides and amino acids, single amino acids and 2 amino acids or 3 amino acids. The single amino acids are transported across the apical membrane into the epithelial cell of the intestine by a sodium amino acid cotransporter. And they are transported out the basolateral membrane by a passive amino acid uniporter. So this looks a lot like glucose and galactose, except that it's a sodium-driven amino acid transporter and an amino acid uniporter. Into the lamina propria, picked up by the capillaries of the intestine. That's the story I want you to know. It turns out that there's another story where short peptides, 3 and 2 amino acids in length, can also get transported by a proton cotransporter, where they are broken down inside the cell into single amino acids, which then go across the basolateral membrane by passive diffusion. What's the main point? The main point is that in the lumen, the proteins are broken down into tri, di, and mono amino acids. Well, amino acids and dipeptides and tripeptides. The amino acids are transported in a sodium-dependent fashion, cotransporter across the apical membrane. Di and tripeptides are transported by a proton-driven cotransporter and broken down inside the cell to amino acids, which then flow out the basolateral membrane down their concentration gradient passively. If you can tell me this story, you're fine. Yes?
That's passive diffusion?
This is passive diffusion on the basolateral membrane. Similar to how this is passive diffusion on the basolateral membrane. So we have a mechanism. Oh, no.
Do we get the tripeptides and dipeptidases, do they get produced inside the cytoplasm?
How do we produce these?
The enzymes inside.
Oh, there are proteases inside the cytoplasm that break down these tri-dipeptides into single amino acids.
Right, so do they get produced in the cytoplasm itself, or do they come from somewhere outside?
The enzyme
Yeah.
is expressed by the genome. This is produced by this cell. So this little balloon here is confusing, but well, it's correct. It says distinct sodium independent, right? Why did they said sodium independent? I'll never know. It's just 3 distinct passive transporters for the transport of amino acids. I don't care that you know this detail. across this detail off your slide. I do want you to know that these are passive transporters, basolateral and co-transport apim. It's a common thread. We've seen that story before. Now, let's circle back to gross anatomy and focus on the complicated blood flow and what I do want you to know. Because why do I want you to know this? Well, it ties together the cardiovascular and the digestive tract system. Well, how could I not love something that ties together the beginning of the course and the end of the course? Tell me how I could not want to do this. Well, you can't, because I do want to do this. So let's talk about the blood flow to and from the digestive organs. So you've seen some of this already. So this is a funny view. We've taken the stomach. The stomach usually sits down here like this, and the stomach has been flipped up. This would be hard to do, but this is an artist taking artistic license, flipping the stomach up so that we can see the blood vessels better. All right, I'm going to scroll all the way back to the very beginning of this. This is the stomach, not flipped up. And there's the artery, there's the celiac trunk. Stomach's been flipped up, and there's the celiac trunk. Okay? So you've seen some of this story. Here is the common hepatic, and then the proper hepatic going to the liver somewhere. We don't see the liver. But this is the hepatic artery that we saw before. So let's talk about how the stomach gets its blood, arterial blood first. We have an artery that serves the lesser curvature. Remember, this is flipped upside down now, so the lesser curvature is here, and the greater curvature is up there. On the right side, so remember this is the person's right side, on the right side, we have coming off of the hepatic, the common hepatic artery, we have an artery called the right gastric artery. This is the right gastric artery. It comes off of the hepatic artery, or the common hepatic artery. To serve the left side of the lesser curvature, we have the left gastric artery, which comes directly off of the celiac trunk. Celiac trunk, left gastric artery serves the left side of the lesser curvature. The right gastric serves the right side of the lesser curvature. Okay? We also have blood flow that serves the greater curvature. On the right side, we've got an artery that branches off of the common hepatic called the gastroduodenal. Gastroduodenal. And from the gastroduodenal branches the right gastroepiploic. Gastroepiploic. Right gastroepiploic branches off of the gastroduodenal, which branches off of the hepatic. On the left side, we have the splenic artery. The This is the splenic artery, and there's a branch from the splenic, you can see it goes to the spleen. That's where it gets its name. But it also serves the pancreas, and it provides a branch for the left gastroepiploic, which serves the left side of the greater curvature. Yeah, so the left side of the greater curvature, celiac trunk, splenic, left gastroepiploic. This slide uses an old-fashioned name, so that you may, I don't know if you're squinting and seeing it, that does not say splenic, because it's using an old name that is no longer in use. These images, this one and the one at the very beginning, are from an anatomy book that's very famous now because it's called Gray's Anatomy. So the TV show is a pun on this classic anatomy text, Gray's Anatomy. Okay, so I do want you to know these anatomical details of blood flow to the lesser curvature and the greater curvature of the stomach.
The last two were for the greater curvature.
The last two are to the greater curvature. Hepatic, gastroepiploic, right sorry, I'll do it again. Celiac trunk, hepatic, gastroduodenal, right gastroepiploic, and on the left side, celiac trunk, splenic, left gastroepiploic. I'll be honest with you, I will not expect you to generate this knowledge from your image in your brain. I would show you an image and ask you to label it.
This wouldn't be on the practical though, right?
No, there's no way I could identify these things on the practical. I could identify the lesser curvature or the greater curvature, but that's about the extent of it. So that's blood flow to the stomach. And just to be clear, there's a left gastroepiploic vein and a right gastroepiploic vein and a right gastric vein and a left gastric vein that parallel the arteries and drain into the inferior vena cava. It's not on the slide because this is arterial, but if you know the arteries, you know the veins. Questions? Let's talk about the arteries that feed the intestines. What are the ones to know? So obviously there's more than I want you to know. So I'm not asking you to memorize the names of 11 arteries. I am not. I told you the names of some of these already, so let's see if they stuck. What's the name of this artery right here?
Upper.
Close. Not upper, but superior mesenteric artery. This is the superior mesenteric artery. What is this one? Inferior mesenteric artery. What is this one? Abdominal aorta. What is this one?
Right, left,
Left common iliac and the right common iliac. So you know some of these already. It's just a matter of bringing them back out of your deep memory banks. The only other name that I want you to know, other than the ones that I've just pointed out, are the names of a generic name for these arteries here that feed into the superior mesenteric. And there's a generic name, they are colic arteries, C-O-L-I-C, colic arteries. They serve the colon, especially the ascending colon. So these are colic arteries. These are actually colic arteries too. So this is right and left colic arteries, but just call them colic arteries. And these arteries here that serve the small intestine, so this is sort of, right? So here's the mesentery of the large intestine. Here is the mesentery of the small intestine. Like here, whether you learn these. Let me see. They've got a name that makes sense, so sure, why don't I ask you to know? The ileal and jejunal arteries, because they are serving the ileum and the jejunum. They are feeding into something that feeds into the inferior mesenteric artery. So what are the names to know? It's not 11, it was superior and inferior mesenteric, colic, ileal, and jejunal. Pretty straightforward. That's a lot easier than all of the 11 random names. And then of course the aorta and the iliac, common iliac. Yeah.
If we merge ileal and jejunal arteries together,
If I told you this is the ileum, what's the name of this artery? You could tell me it's the ileum. But if I didn't tell you that, you would have to say either ileal or jejunal. Now you may be wondering, well, what about the duodenum? It's got to get blood too. It gets blood from the gastroduodenal artery. The name helps. Gastro means it's giving blood to the stomach, especially the right gastroepiploic, and to the duodenum. Right there, there's the duodenum. Complicated blood flow. Let's talk about veins. Because here, the veins are just as important as the arteries, right? This is where the nutrients are getting from the intestines into the bloodstream to go to the liver. So you know the names of some of these. What's this one right here, going sort of behind the liver? Big vein goes behind the liver. You've seen it in the cadaver. You know the name. The inferior vena cava. What's the name of this vein? Taking the blood from the intestines to the liver. Portal vein. That's the portal vein. So number 16, well, it's right here. Number 6, let's highlight the ones I want you to know. I want you to know the portal vein. 16 is the portal vein. I want you to know number 1, the inferior vena cava. Okay, let's just go through them, not in order, but in anatomy. What is this one? If this is the superior mesenteric artery, what do you suppose this is? Superior mesenteric vein. If this is the inferior mesenteric artery, what do you suppose this is? The inferior mesenteric vein. Let's see, number 7. Remember, this is the greater curvature. What was the artery that served the greater curvature? gastroepiploic. So this is the gastroepiploic vein. And we've got a right side and we've got a left side. Right and left. What was the artery that served the lesser curvature? The gastric artery. So we've got a gastric vein, two. Gastric, left and right gastric vein. Notice how the gastric veins feed into the portal vein, which is going to take the blood to the liver and then into this inferior vena cava. I think I said something wrong just a few minutes ago. I said that these veins are going to drain into the inferior vena cava. I left off the fact that it's got to go through the liver first. It's got to go through the liver first, because that's where the nutrients from the stomach and from the intestine go before it gets into the general circulation. So, gastric vein, portal vein. Gastroepiploic, superior mesenteric, portal. Inferior mesenteric, portal. Okay? So let's go through the list and see what I want you to know. I do want you to know inferior vena cava. Gastric, yes. Splenic, no, but it's easy. The vein that parallels the splenic artery, which I do want you to know, is the splenic vein. Gastroepiploic, yes. Inferior mesenteric, yes. Colic, no, but again, it's the veins that parallel the colic arteries are the colic veins, so it's easy, but you can cross it off your list. Sigmoid, no. Jejunal and ileal, same idea as the arteries. The veins, these are important, right? These are the veins that are taking nutrients from the small intestine, which is where a lot of the digestion happens, and taking it to the venous circulation to the liver. They're critical. But if you know the names of the arteries, you know the names of the veins. So don't cross this one off. It's just easy. This is what I'm saying. You might say nothing's easy, but I understand. Ileocolic, no. Right colic, no. Middle colic, no. Just don't. Superior mesenteric vein, yes. Pancreatoduodenal, no. Just don't. Portal, yes, absolutely. Hepatic, right, yes. Portal vein in, hepatic vein out of the liver sinusoids to the inferior vena cava. So portal vein, branching, sinusoids, hepatocytes, central vein of the lobule connects to the hepatic vein, which connects to the inferior vena cava. That's what I want you to know about blood. And like I said, cardiovascular and the digestive, the very beginning of the course and the very end of the course, are now satisfyingly needed. Let's finish with water. So you drink about 1 liter of water a day, maybe more. You get about a half a liter of water from your foods. You secrete 1 to 2 liters of saliva, that's mostly water. You secrete about 2 liters of gastric acid a day into the stomach. You pump about a half a liter of bile and another 1.5 liters of pancreatic juice, enzymes, zymogens, bicarbonate. So look at all this input. I mean, you're only aware of your 1.2 liters that you're drinking, but 1.2, well, you can do the arithmetic. a lot of water is going into the digestive tract, and you know you don't excrete that much water, at least you shouldn't be. If you do, you're going to get dehydrated super fast. That's cholera. So the large intestines, well, the small intestines absorb a lot of water, and the large intestines polish it off and absorb another amount of water, so that you excrete about 100 milliliters of water a day from your digestive tract. Now, you know you produce a lot more than that from your kidney, right? What is 1 mil per minute? That's 1.4 liters a day from your kidney, and less than that from your digestive tract, but it's still an important excretion. The point is that we excrete and then reabsorb a lot of water in the digestive tract. And if we don't do this reabsorption, we've got diarrhea and we dehydrate super fast.
Is the absorption the same concept as the kidneys?
So this is all, so is it transcellular or is it paracellular is your question? And the answer is both. So there are aquaporins and there are leaky junctions. And so in the intestines, this water is following solute, right? Remember the absorption of amino acids, glucose, and other monosaccharides. So it's all passive. Some of it is transcellular and some of it is a paracellular. Let's stop here. Well, this is the end. So let's stop here. On Wednesday, we're going to try to do some homeostasis, try to link the whole course together, talking about blood pressure, now that we know pretty much a lot more about the circulatory system. So again, tying it back to blood pressure, reviewing how the digestive tract changes acid-base balance, during the gastric phase or during the intestinal phase. We can have either metabolic alkalosis or metabolic acidosis. One after the other, actually, if we eat a big Thanksgiving meal. Anyway, Wednesday we will have a short-ish class that tie this together and talk about homeostasis.